Hello friends, I am Manas from ARYABHATTA Career Academy. Today in this video, I am going to explain ideal gas equation and absolute temperature. This is just part 2 of thermal properties of matter. In the previous video, I explained different scales of temperature. Today we will see about the ideal gas equation and absolute temperature. What they mean by ideal gas? In fact, in practice, there is no ideal gas. No gas is ideal. So, this is one assumption to find some numerical problems. So, let us start. What is that ideal gas? In fact, ideal gas is one in which the collision between the molecules or the collision between the atoms, you can say, perfectly elastic. Collision among the molecules perfectly elastic. There is no intermolecular force of attraction. No intermolecular force of attraction. You can say that, for example, some hard balls are there. These balls we are throwing, they may collide with each other. But you won't find there is any attractive force among these hard spherical balls. So similarly, in ideal gas, we consider how the molecules collide each other. That should be perfectly elastic. There should be no intermolecular force of attraction. In that condition, that gas we can consider as an ideal gas. So children, I said that there is practically no ideal gas. This is an assumption, hypothetically you can take just to solve some numerical problems. So let us move forward. See here. Suppose this is a container. You can say that I have arranged one piston. Inside that, we have taken certain mass of gas, or you can say that here the number of moles are constant, fixed. Suppose I shall apply force per unit area, that is pressure. That means if I apply the pressure, what will happen? There will be change in volume at constant temperature. That means when the pressure will increase, volume will decrease. What we have studied in Boyle's law. So in your high school level, you might have studied about the Boyle's law. So according to this Boyle's law, V is inversely proportional to P, where N and T both are constant. So here N means number of moles, T means temperature. So I said that according to Boyle's law, at a constant temperature, the volume of a given mass of gas is inversely proportional to pressure. V is inversely proportional to pressure. So, the condition is that number of moles are constant and temperature is also constant. Similarly, if I consider the Charles law, from the Charles law we know that V is directly proportional to T. Volume is directly proportional to temperature, but the condition is that both A and P are constant. Number of moles are fixed, pressure is fixed. If the pressure is fixed, volume will increase with the increase in temperature. Listen carefully. Suppose we are supplying some heat here. This is the volume of the gas fixed inside this container. The number of moles are fixed. But if I supply the heat, the molecules will start to move with more speed. They will get the kinetic energy. As a result, they will try to move. So the volume will expand or the volume will increase. So from Charles' law, we have learned that volume is directly proportional to temperature when both number of moles and pressure are constant. So this one I can say the second equation. Similarly, from ARYABHATTA's law, we have studied that volume is directly proportional to number of moles of a gas. The condition what? Under similar conditions of temperature and pressure, here T and P both are constant. Under similar conditions of temperature and pressure, equal volume of all gases contain equal number of molecules, or I can say that V is directly proportional to N. This is the third equation. So if I combine these three equations, what I shall get? Can you tell me? See here, V is inversely proportional to P, V is proportional to T, V is proportional to N. So I can say that V is proportional to NT. If I remove this proportionality symbol, I can write that implies that PV is equal to nRT. This is called ideal gas equation. This is ideal gas equation. Here N is the number of moles, R is a constant. This is called ideal gas constant. Ideal gas constant, or you can say Boltzmann constant. So this is about the ideal gas equation. Just we will go through it graphically. Suppose from Boyle's law, we know that V is inversely proportional to P, or I can say that PV equal to constant. In a graph, in the x-axis, if I take the pressure, and in the y-axis, if I take both pressure and volume, how the graph will be? Definitely the graph will be a straight line. So because whatever the pressure may be, according to pressure, volume will change. So if I draw the graph will be like this. That means the pressure and volume all the time is constant. Now let us see one more graph. Suppose we'll take the graph of volume versus temperature. This is the temperature in degrees Celsius, and here I have taken the volume. Okay, X axis we have taken the temperature, Y axis we have taken the volume. So whenever according to Charles law, volume is directly proportional to temperature. Whenever the temperature will increase, suppose from this at this temperature, this is the volume. At this temperature, this is the volume. At this temperature, this is the volume. So if I join this one, I shall get a line which intersects the x-axis here. So definitely the point where it is intersecting, that point gives the absolute temperature, what we say 0 Kelvin, or we say minus 273 degrees Celsius. So in the x-axis I have taken the temperature in degrees Celsius. So the line touches the x-axis in this left side, in minus side. So the temperature is in minus 273 degrees Celsius, which is called the absolute temperature. Means at this temperature, the kinetic energy, the average kinetic energy of the molecules of gases are 0. The molecules are not moving at this stage. So we can't go beyond this temperature. This is the least possible temperature where one substance can attain, because at this temperature the molecules are completely rest. There is no movement, there is no kinetic energy. So we can't go more or less than minus 273 degrees Celsius. So this temperature is called the absolute temperature. So here temperature we have taken x-axis, whereas volume we have taken in the y-axis. Suppose I shall take temperature in the x-axis, pressure in the y-axis. Temperature, this is the pressure. So temperature and pressure, whenever the temperature increases, pressure also increases. The molecules start to move randomly with high speed, with higher kinetic energy. They collide with the walls of the container. They collide among themselves. They collide with the walls of the container. They create more pressure. So if I plot a graph by taking the pressure in the y-axis and temperature in the x-axis, the graph will be like this previous case. That means here also we got minus 273 degrees Celsius, which is 0 Kelvin. That is called the absolute temperature. At what temperature molecules are completely rested, they don't have any average kinetic energy. So this is about the ideal gas and absolute temperature. Let us go through one small example. For example, question number 1. We'll take about the, suppose, a solution of nitrogen occupies a volume of 1 liter at a pressure of 0.5 bar and temperature 40 degrees Celsius. For example, I have taken solution of a nitrogen which occupies a volume of 1.0 liter at a pressure of a 0.5 bar and temperature 40 degrees Celsius. So Suppose calculate the pressure when the gas is compressed to 0.225 bar at -6 degrees centigrade or Celsius. Listen carefully. A solution of a nitrogen occupies a volume of 1.0 liter. That means the V1 is equal to 1.0 liter. At a pressure of 0.5 bar, that means the pressure is given 0.5 bar. Okay, that bar is the SI unit of pressure. We can say also that is atmosphere. Okay, so T1 is given 0.5 and the T1 is given T1 is equal to 40 degrees Celsius. We convert into Kelvin scale. So 40 plus 273 is equal to 313 Kelvin. So V1, P1, T1 already given. Calculate the pressure when the gas, that means we have to find the P2. When the gas is compressed to 0.225 bar, okay, that means the pressure, 0.225 liter. Okay, pressure when the gas is compressed to 0.225 liter at -0 degrees Celsius is correct. Now the pressure is given, we have to find out the pressure. Volume is given, V2 is equal to 0.225 liter and the temperature T2 is given -6 degree Celsius is equal to -6 plus 273 is equal to 267 Kelvin. So easily we can kill it. How? So we'll use the combined gas law to solve this answer. At first, whenever you are solving the problem, at first you have to read the statement. Second, you have to write the given points. Third thing is that we have to check whether the units are similar units or not. After that, we have to see that which formula we are going to apply. After deciding the formula, we have to go for the solution. So here, pressure, volume and temperature, that means combined gas law for Boyle's and Charles law we can use. So P1 V1 by T1 is equal to P2 V2 by T2. So I can say that this P2 V2 T1 is equal to P1 V1 T2 implies that this P2 is equal to P1 V1 T2 upon V2 T1. So easily you can put these values. Everything is in the similar units, no need to worry, you can get the solution. So shall I say one more problem? For example, a sample of nitrogen gas. I have given a sample of a nitrogen gas at STP which occupies 56.2 liters. So you have to calculate the number of moles of nitrogen. You have to calculate the number of moles of nitrogen. What you have to do? What is given? Sample of nitrogen gas at STP. So I want to clear what is SP. This is standard temperature and pressure. Here standard temperature means we say 0 degrees Celsius, or you can say this is 273 Kelvin, and the pressure is standard pressure. We consider 1 atmosphere. Okay, or we can take 1 bar, or we can say 76 centimeter of mercury. This is about the STP, standard temperature and pressure. So we have to calculate the number of moles. So directly we can use the ideal gas equation, which is PV equal to nRT. PV is equal to nRT. So R is the constant, T is the temperature. I said it is the standard temperature. Standard temperature means that is 273 Kelvin. Okay. So we can calculate N equal to PV upon RT. So what is P? P is the pressure. Standard pressure. How much given? It is given 1 atmosphere. Volume how much given? This is 56.2 upon R. R is a constant of proportionality. Its value is 0.08206 liter per mole per Kelvin into temperature. Temperature here is the standard temperature. So we can use 273 Kelvin. Now easily you can solve it. So children, in this small video, just I explained what is ideal gas and its gas equation with the absolute temperature. So in the next video, definitely we'll go through the thermal expansion. So for this video, this is enough. Thanks.